All right, so this week we're going to talk about dictionaries and how to structure different data. So if we go back and recover all the data types that we've used so far, we have the main three, which was string, integers, and anybody remember the third one? Floats. Then we talked about lists as another data type. We talked about Boolean, which was true or false. We talked about null data type, which is just none. Or the none data type is none. And so this one is dictionary. And a dictionary is basically a mutable collection of many values. It's kind of like a list in that way. However, instead of indexes like numbers, indexes for dictionaries can use many different data types as well, not just numbers. So for indexes within dictionaries, they're called keys. And a key with its associated value is called a key value pair. So for example, if we look at this one here, we set up a dictionary, we're going to say something like, I think their example is my cat equals, and then we're going to use the squiggly brackets for dictionaries. Those indicate dictionaries. So you can have something like this, which is size, and then we can put whatever size we want in there. So we can be large. We can have another key value pair that would be something like color. And then we can put a color in here like gray. We can have age, and then we could set an age. This can also be, an integer or whatever we want it to be. And then you can end the dictionary there. So you can run these on the same line, just like this, or you can line them all up so it's a little easier to read. So size in this case, color, and age are going to be your keys. Your values are going to be large, gray, and 29. So this would be similar like when we did a list earlier, right? We had my cat equals, and then we had something like large. And then we had gray. And then we had something like 29. That's a list. And then we use the multiple assignment trick to actually assign variables to that list. So we did something like size, comma, color, comma, age equals my cat. Now at that point, anytime I type in the word size, I'm going to get back the size that was here. So it would come back as large. If I typed in color, I'm going to get gray, and age is going to be 29. But instead of having to do this multiple assignment and have all these different variables, we can use a really nice dictionary, which has those specific indexes the way we want them to be. So instead of dealing with 0, 1, 2, 3, all the way up in indexes, we can specifically state whatever we want. Now, this could be a string, it could be a number, could be whatever data type we want, it could be a list even on that particular part. In the same way with the values, they could be anything, any data type that we've talked about so far. So the main differences between dictionary and lists are that dictionaries are unordered, right? So in a list, they're ordered. We have a clear index from 0 to whatever we get up to. But in a dictionary, nothing is ordered. And you can't sort based on an order because it's just an unordered item. So there's no first item within a dictionary. And while the order of items matter to determine whether two lists are the same, it does not matter in what order two key values are typed into inside of a dictionary. So if we look at their example here, and I'll zoom in a little bit, we can see that spam equals cats, dogs, and moose. Bacon equals dogs, moose, and cats. We'll notice that spam is not equal to bacon. And that's because even though they're the same words, they're in a different order, which makes it a completely different list, because these are based on index. However, if we do a dictionary that looks like this, where eggs is equal to a dictionary with a key value of name, a value of Sophie, we have a key of species, a value of cat, a key of age, and a value of 8. And then if we were to do a mix-up of that in a dictionary, this will equal true, because there is no order to dictionaries. Anybody have any questions like that? All right, so because there is no order, you cannot slice dictionaries like you do with lists. So if we only wanted a portion of that dictionary, we can't slice it out to say index from 1 to 3 because there's no order to it in order to do that. If you try to access a key that doesn't exist in a dictionary, you'll end up with a key error, which will say it's something like list out of range. So for example, if we look at this one, we have a dictionary here and we ask for color. We're not going to get anything back because there was no key named color. You'll notice that when we call this value, instead of us passing in the index number here, which we've been doing with 0, 1, 2, 3, etc., now we just pass in whatever key value we want to return. So if I have this dictionary that we have over here, I'm just going to put this into the interactive shell so that we can play with it a bit. All right, so if I type in my cat, we can see I get back that dictionary. If I type in my cat and I want to get back the size, I would get back large. So we just pass in whatever key value you want, and that's how you can call that out. So age, we get back 29. But what's nice about this is it allows you, a lot of times you'll have two different lists, right? To sort and organize data and keep extra information. That's what's nice about a dictionary is you can have the own values that you want for keys, and then you can turn whatever values you want into that. And again, you can have a list in here as a value as well. So we could say pets is my key, but I have multiple pets. So let's say we have a dog, we have a cat, we have a bird, and we have a reptile of some sort. So we can see that I have a list as my value. And so anytime I would call pets then to get that out of here. Give me a second, I forgot my comma. So now if I call my cat, which doesn't make as much sense when we did pets, we could say pet, and we're going to get back a list. If I could spell it correctly, my cats equal pets. Nope, how we get a, am I still not spelling it right? My cat, it's just my cat. Something like that, we would get a list back. So the same way that we did for loops before, we could say for pet in my cat pets, because that returns a list to us. So then we can do a for loop through it. We could print our pet. And we would get it to actually print out each individual one out of that list. Okay. So again, dictionaries are, to me, a far better data type if you're going to store things, but there's reasons that you would want to use lists. If you want any kind of order to things, like the order that you added them to a list, etc., then you would want to use a list anytime you need some type of order. But dictionaries are pretty beneficial, so you can use multiple ones. There is a way of doing somewhat ordered dictionaries in Python 3.7. So you could do something like this, where you can convert eggs over to a list, and then it's just going to drop out the key values basically into this, and then you could do a sort on that, and you could get those out of there as well. So we won't cover too much of that, but there is ability to do some things different in 3.7. So that does bring us to the different methods that you can use on a dictionary. So if you remember the methods that you could use on a list, you had things like append, you had remove, you had index, where you could get the specific index. So there's a bunch of different methods on a list. In a dictionary, the three main ones are going to be keys. So if I went mycat.keys, that's going to return me a list of all the key values that I have inside my dictionary. We could also have mycat.values. That is going to return back all the values out of my dictionary. And then we have mycat.items. Now that's going to return a tuple. Remember, a tuple is an immutable item. So we're going to get a tuple back of the key and the value. And so for a lot of times, we'll come over here to our interactive shell. Let's take a look again at my cats, or my cat. We have a dictionary, If I want to get back all the keys, it's just mycat.keys. Notice how we get what looks like a dictionary or a list back. It's called a myDictKeys, and we can pull that back. Now, there's certain things that you can do with that, and sometimes you have to convert that over to a full-on list in order to be able to use it like a list. But for the most part, you can treat it like a list. So mycat.values, we can see we get back what looks like a list of all the values inside of there. And if we do a mycat.items, you'll see we get back a list of tuples, and each tuple corresponds to the value of the key and the value pair. So if we want to print things out, just like I showed you earlier, we could say for key in mycat.keys, print key, and you'll see that we get all the keys out of there. We could also do for value in mycat.values, print value, and we get all the values back. If we want to be able to print these back or use something fancy for the items, say we want both the keys and the values back, we would say for K comma V. Now we could use whatever we want, right? We're just assigning value names, but we're going to use K for key, V for value. For K and V of in mycats dot items, we could say print, and we wanted to print K, whatever the K value is, plus a colon space plus whatever the value was. And we could do that in this fashion. And you'll see when it comes up, obviously it doesn't have my cats because I typed that wrong. So give me a second. 4K comma V and my cat dot items. I'm just going to copy this. You can see it will do it for size large, color gray, and this way we could get kind of this nice little printout. The problem is when we get down to age, it becomes an integer, right? So we have to make sure that when we do these type of printouts, that one, if we're going to do this string concatenation like this, that we always want to convert whatever that value is over to a string first. So we would do string there, and we would need to convert this one to a string in order to get that out. Now we can avoid that, and we'll show that here a little bit later with some fancier prints. But for now, this would be a great way to print out a dictionary. So when I ask you to print out a dictionary, or you're going to print out a dictionary in your project, don't just show something like this. My cat, don't print something like this on the screen. It's meaningless to the end user. They don't understand what's going on. But for this one here, we could see that this is much easier for the end user to read. Now, even for pets, we shouldn't be dumping this list out to a screen. So what we could do is say something like for K comma V in mycat dot items, if V, or in this case, if type V equals, and it's going to become a list, then we could say print str K plus V, something like that. We're going to get the V out of there. Then we want to loop through the V. So instead of printing that at the end, we'll go here, and then we can say for item in V, print V. So here we got pets and it came in there, but we got to get this equal to right. But the idea would be that we would make a much better printout for these. We could actually tab them over and print them down in a nice line. But we would have to get the type back as that. So if we do type, let's do it this way. It's created a blank list. So it's going to be and we say type my list, This is the class list that we're going to get back. So we could copy something like this and we could put that into here. So if I take this, I'm going to put this over here where we can actually play with it. Okay, and so instead of saying that it's a list, we're actually going to go with this class list. I've actually not done it in this fashion, so we're going to try it, see what happens. There's probably other ways to do this. Yeah, it doesn't like that syntax. So we would have to figure out how we could get the type V back to see if that's actually equal to that. So it would take a little bit of research. But we could see if we end up returning a type of some sort, and then we could print that out. So that would be a little mini function. We're actually going to work on that inside your homework this week. All right, so you've understood how to get values out of things. You understand how to get keys out, and you understand that if you do items, you're going to end up with a tuple, and that you could use the multiple assignment trick inside of here to do K comma V so that you assign the key to a K and a V to the value. All right. Remember that when you return a keys or a values, it looks like a list, but it's not necessarily a list. So you may sometimes have to check that. Inside of our list that we had in here, which I closed. Pull back up the dictionary here. All right. So if we wanted to check to see if a value or a key was in our particular dictionary, we could just do a check. So we could say if name in my cat dot values. Of course, we would have whatever this name is inside of here. And if we run this, we would have to print this back because it's going to print back a true or false, right? So we could do a run and we could get back false because we're going to find out that name is not in the value side of things over on this side. We could also check it for keys. And we'll also get back false because name's not over here. But if we actually put size in here, you'll notice we get back true. So we could do this like this isn't as beneficial for us, but this is where we could say if size in keys, then we could print something. Or we could say else. And so if we run this now, we'll get back true. Therefore, size is in there. Now, instead of doing this, we could actually see something that they input. So if we called this my input, and before this, we say print, what would you like to test? My input equals input. And now we can actually run this and it becomes more like a program we would use. So what would you like to test? We could say size, and size is a valid key. So you could reword this obviously and say, what key would you like to test or something like that? And that would make more sense. So if we type something like name, it'll say name is not a key or that is not a key. All right. You could also do the opposite of that, which is beneficial. So you could say if my input not in my keys, then you would just flip-flop this order. That way we could print an error. Otherwise, we don't even need an else. With this other direction, within, we have to have an else, right? We're either going to check if it's in there or if it's not in there, we got to tell them something. But if we switch this to not, then we could simply say that's not in there. Change this out. We don't need an else. And then it's either in there, it's going to continue on, or else it does the opposite. You can also use the get method. So the get method, what that's going to do is try to return something out. So if we check, instead of doing a check on there, then using a try and accept to find out whether or not it existed or not, then writing other code, we have what's called a get method. And what that's going to do is take two values. It's going to take what is the index or the key that you want to get from. In this case, it's keys because we're in dictionaries. So what key do you want to get? And if it doesn't exist, you can tell it to give me a default value back as opposed to giving me an error. So if we look at this example here, we're saying here is our dictionary. Apples is 5, cups is 2. We ask for cups. If cups didn't exist, we would get back 0. But because it does exist, notice how we get back 2. So in this one, we ask for eggs. Well, eggs doesn't exist inside the dictionary, and therefore we're going to get back the default value of 0. So you can ask for something, and if it doesn't exist, you can tell it what you want it to default back to you. If it doesn't exist and you would like for it to exist, then you would use the set default method. So set default says it's the equivalent of doing this particular dictionary. So name is Puka, age is 5. If color not in spam, so color is not a key, then set spam color equal to black. Well, instead of having these multiple lines, we can use the set default method, which will do the same thing. If color does not exist in spam, then we're going to set it to black. And therefore, the next time we go and look at our black or spam dictionary, we'll see that black is actually set. Pay attention to how set default works. This is going to be on a quiz or exam. So yes, you could do code that looks like this, but the shorthand way of doing that is just a simple one-liner here called spam.setDefault. Anybody have any questions how that works? So you're all going to get it right on the midterm and you won't forget that? Okay. So that gets us through set default. When we try to print a list, which we've talked about, or a dictionary here, remember if I have something like print my cat over here, right? When it comes out on the screen, it's going to look like this. And this isn't very legible. This is kind of hard to read when it's over here as a dictionary. In a list, we would typically just do a for loop, right? This is what we just talked about before, where we could somewhat make that pretty. Well, speaking of pretty, we can import pp print, which is pretty print, and then we could pretty print any dictionary out here. So we would say pp print my cat. And this is going to print it out a little bit more organized over there on the left-hand side so that you can kind of see how it prints it out. So if you have a bunch of data, it would print it out even cleaner. And this is called pretty print. So you have to import pretty print, then you have to call pretty print on whatever's coming inside of there. Note it still prints it out as a dictionary and in a dictionary format. So I would ask if you're on your midterm project that you don't necessarily use pretty print, that you actually find a better way of printing this information out, which means you may have to write a function in order to print that out cleanly. But it's a great way if you're testing large amounts of data inside of a dictionary. So like right now, we're just talking about a few things in the dictionary, but you can store a lot of things in a dictionary similar to like you would with a database. So for those of you that deal with databases and other programming languages, you can treat a dictionary like a database because it has a key value pair, just like you would see in a database. So in real life, where would you use data structures like this? You could think of it as a coordinate system in a game of chess, right? So we could say a key value of A, and then the value is whatever spot we're in on the chessboard. So we can store these different coordinates on the chessboard to store where that person's going. So for example, if we had a dictionary of 1H, we have the black king sitting in there. In 6C, we have the white queen. 2G, we have the black bishop, etc. And we could represent this board with this simple dictionary. All right. If we're playing a game of tic-tac-toe, same way, we could have corresponding coordinates in where this is the top left, top middle, top right. So when you ask for what spot do they want to put something in, you could put an X or an O in there, or you could have a space in there, meaning that they haven't put anything in that spot. And this way you could create your own chess game. You could also create your own tic-tac-toe game. So if you looked at this as a board, you could call it as the board equals, and then you would have this dictionary where there's empty. And so you would have this empty tic-tac-toe board because we have spaces in there. Now note, this isn't going to necessarily show up that way. You have to write some more code for that to work. But if we wanted an X in the middle, then our board would look something like this. If we had a bunch of X's and O's in there, then you can see how we can update the board and put X's and O's in different spots where they belong. Now, again, if you want to print that out to where a user can see it, you're going to have to create a function to print the board, which is what they did here, in which case they print the top left, then they concatenate a pipe symbol in there. They can then use string concatenation to add the top middle and then the top right. And so anytime they want to print the board, you would end up with something like this as your tic-tac-toe board. If you actually had X and O's in there, then you would end up with something like this, right? So this is the command line way of playing tic-tac-toe. It doesn't look that great on this screen. It looks better on a command prompt. So for example, if I take this out here and shove this into our test file we've been playing with and run it, we can see that we actually have what somewhat looks like a tic-tac-toe board. So I encourage you to work through these exercises. It will help with you understanding how dictionaries work. You will need to use dictionaries in your projects of some type. Now you can do nested dictionaries. So if we look at this, we have all guess equals a dictionary. Inside of that, we have a key of Alice, and then Alice has a bunch of different items she has. So she brought 5 apples and 12 pretzels. We can see that Bob, and then we have a dictionary for him that has ham sandwiches 3, apples 2. Carol brings 3 cups and 1 apple pie. And so if we wanted to print this thing out, we could print it out with this little function here, and we'll get a nice little output that says number of things brought, how many people brought one thing. And we could add that up. All right, does anybody have any questions over dictionaries? I, again, highly encourage you to go play through these practice dictionaries and the practice projects in here. One thing that we're going to get to is the homework assignment this week. So I believe it's this week. Let me double check. Should have been. Okay, it got moved to after we do manipulating strings. Okay. So you will need to pay attention this week. You just have a quiz over lists and dictionaries over the data that I just talked about, and how you would structure that. Next week, when you go through that homework assignment, it's going to use everything you learned in lists, everything you learned in dictionaries, and how you would manipulate strings. And it's a pretty, I won't say rough assignment, but it was one question on a midterm that I used to ask. Everybody failed the midterm because they were so stuck on that one project in the midterm. So it used to be extra credit. Now it's actually your homework 3, because I had a lot of issues with students trying to cheat in this class on the old homework 3. I encourage you not to do that. And just as a forewarning again, although there should be no chance of you doing that now, the way I've structured it, don't cheat in this class. Please don't cheat in this class. I've failed way too many students in the last year and a half for cheating. Some that were looking to graduate, and this was the last class they needed. They didn't graduate because I had to fail them in this class. Then they go on academic probation for academic dishonesty and have to go through that whole board. Please don't do that. Again, I removed those assignments that were pushing students to go out on the internet, Google it, and just copy and paste off Stack Exchange. That failed miserably for them. So please don't do that. Specifically when we start talking about your midterm projects. Don't go on the internet, copy somebody's project off and put it in there. Trust me, after seeing hundreds of students in this class and teaching it for 4 years, I can use Google just like you guys. Probably a little bit better, because if I didn't, I wouldn't have this particular job in cybersecurity. All right. I know it sounds like I'm harping on that, but it really felt bad dropping almost 30 students last semester. There's only 75 students. So almost 50% I had to fail. Okay. So this week we'll have the quiz. So on Thursday, you guys can take the quiz in here. You can take it at home, however you want to do it. Let's see. It'll be due by Sunday. Yep. Drew, you have any questions? Okay.